Today we're going to be reviewing for our upcoming quiz for lessons 2.1 through 2.5. This is for the algebra students. Here we're asked to translate the verbal sentence into an equation. So we're going to look for keywords here to tell us what to put for our equation. We need to look for operations, and we need to look for numbers, and we need to look for variables. So the first thing that stands out to me is it says the difference. So the difference of, and then we're thinking about what is being subtracted here. Well, it mentions the square of x and 10. So if we square x and we have a 10, it's telling us the difference. So that means x squared minus 10. Usually with subtraction you go with whatever is listed first, unless it's saying fewer than or less than, then you probably will need to go with what's listed second as your first part of your subtraction. But in this case, there's no less than or fewer than, so we're going to say x squared comes first, and then it's minus 10. Then it says is the same as. That's going to be your equals. And then finally on the other side we have the product of 15 and y. And we usually write the number first when we multiply, so 15 times y would be 15y. And that would be my answer. Here we're asked to translate the equation into a verbal sentence. So we're going to take again and look for operations and numbers, and we're going to represent them with words. So we're going to write out 3, and we're not just going to write out 3c, we need to write out that it's 3 times c, and then we could just write the word minus, and 12, so we have 3 times c minus 12, and we could just put the word is, or we could do is the same as, or is exactly the same as, or any kind of sentence that has is really is going to work here. So is, and then it's equal to 3, so we write out the word 3, and that would be our answer. Here we're also asked to write this out in words, so we're going to have the letter x, or we usually say a number. The phrase a number represents the variable. So a number, x. Then we have plus, so we write out plus. And the number 2. We could do is the same as to represent our equals this time. And we could say either 4 times y, or we could say the product of 4 and y. You don't have to get too fancy here. You could just say 4 times y, so that's what I'll do. A number x plus 2 is the same as 4 times, y. Or we could do times a different number, since x and y are different variables. But that would be our answer. Here we're asked to solve, so we're going to solve for x here. We need to look on the side with the variable when there's only one variable involved, and that says x minus 7. So our goal is always to get the variable by itself, so in this case we want to get x by itself. We look at minus 7, and to get rid of, or to cancel, or to make this become 0, which is really what I mean by that, is we need to do the opposite operation or sign. So in this case, it's the opposite operation, and that would be plus. But really, if you are confused about whether to use the opposite operation or the opposite sign, you need to just think about how can you get the number to be 0 when you're adding and subtracting. So in this case it was a minus 7, that means it's a negative 7. So either way, if we think about it as minus 7 or negative 7, we would need to add 7 to get that to be 0. So that cancels out, and we get x equals 8 plus 7, 15. All right, next one, negative 10 equals q plus 20. We're going to solve for q, so this time we're going to take the 20 away. It's plus 20, so we need to subtract 20. And like I always say, whatever you do to one side, you have to do to the other. So the 20s cancel out, and we get q equals negative 10 minus 20, which is negative 30. And that would be our answer. And when you're doing these types of solutions and solving equations, you always want to, in your head at the very least, put back the number that you got for the variable and see whether one side equals the other. If that's true, then you know that that number for the variable is the solution. If it's not true, then you probably want to go back and see if you messed up anything during the process. So this one, we have negative 6x equals 36. In this case, to cancel out negative 6x, we need to, the negative 6 with the x, we can't just look at the fact that it's negative 6 and add the 6. What we have to do is think about how can we get the number to be away from the variable and cancel it out. So in this case, we want, when we're dealing with multiplication and division, we want to think about how can we make the number turn into the number 1. So this would always have to be, with multiplication and division at least, always have to be the opposite operation. We actually keep the fact that it's negative 6. So since it's negative 6 times x, we need to divide by negative 6. So x would be 36 divided by negative 6. Since we have one negative and one positive, that means our answer is negative when we're multiplying or dividing. So it's negative 6. Our next problem, we have negative x over 7 equals negative 10. Since we only have one negative sign with the x over the 7, I always apply it to the number part of the fraction. Okay, so I'm going to apply it to here to be negative 7 and just cross out the negative part there. You can apply it to the x, but I think that adds an extra step to your solving, so I would just always apply the negative symbol. If it's in the middle of the fraction, I would apply it to the number part of the fraction. Or even just the denominator part of the fraction would work. So in this case, this is x divided by negative 7, and again, we're not going to change the sign of the 7. All we're going to do is do the opposite operation, since we're dealing with division. So division, the opposite would be multiply. So I'm going to multiply on both sides by negative 7. And what that will do, we'll cancel it out with the x. And we're going to multiply over here by negative 7. So I get negative 10 times negative 7, which is going to be a positive 70 because you have two negatives. When you multiply or divide two negatives, your answer is positive. And we're continuing to solve different types of equations here, so I made sure to include all the different types of equations you might see on your quiz. So in this case, we have two-step equations where we're still solving for x, but we need to look at how to cancel out what's not directly with the variable first. So in this case, what I mean is what is either added or subtracted. So we need to cancel out the plus 2 first, and we need to do that by subtracting 2 to both sides. And then we need to cancel out the 2 with the x. So that means 2 times x. So I'm going to divide on both sides. So x would be 12. This one we have b divided by 2, or b over 2, minus 4 equals 12. In this case, so again, we're going to cancel out the 4 first. That's a minus 4, so we're going to add it to both sides. And then we need to cancel out the 2. And that's b divided by 2, so I'm going to multiply by 2 to get b equals 32. Next we have variables on both sides. When we have variables on both sides, it doesn't matter which side we start with, but our goal is still ultimately the same, to get the variable by itself. So what we need to look at first is if any of the sides of the equation need to be simplified, meaning combining all the like terms before we start combining like terms across the equal sign. So in this case, we cannot combine 6n and 2 because one has a variable and one does not. We can't combine 2n and 10 because one has a variable and one does not. So both sides are simplified. So I'm going to start by combining. You could either combine the variable terms first or the number terms first. But if you're going to combine them, think about how you could make it so you're dealing with mostly positive numbers. If you think you can get it to be mostly positive numbers, doesn't really matter. Ultimately, if you do this correctly, you should get the same answer no matter where you started. But I'm going to start by combining the variable terms, and I'm going to bring the 2n to be with the 6n, because that way I'm going to still have a positive variable term. So 2n, if I think about the whole thing, 2n, and I want to take it from this side and bring it to the left side, I need to subtract the whole thing. If I were to divide by 2, that would only be canceling out the 2. It wouldn't be canceling out the n. And since I need to combine the n variable term with the other n variable term, I need to take the whole term and move it over to be with the 6n. So that means I need to subtract it. Now I have 4n plus 2, and the minus sign goes with the 10, so now I'm bringing this down as a negative 10. Now I would combine my number terms. So I'm going to cancel out the 2 by subtracting, and I get 4n equals negative 12. Then I would finally divide by 4, because I want to get the n by itself, and I'd have negative 12 divided by 4, which is negative 3. Again, here's another example of variables on both sides. I'm going to look on the left side. You can see actually that the left side you can combine the like terms first before we combine them across the equal sign. So I have 2, and I'm reading from left to right here because it's subtraction and addition only. So 2x plus 3x, because the minus part actually relates to the 12. So this is not with the exit. So 2x plus 3x is going to give me 5x. I still have the minus 12. And then on this side I have 5x plus 2. And we talked about this where you have the same variable terms but different number terms. So in this case we have the same exact variable terms. They're both 5x and positive 5x, but we have different number terms. So in this case we can stop at this point in solving, and we put no solution. Now if it had same variable terms and same number terms, meaning the exact same expression on one side as the other side of the equal sign, then I would say all real numbers at this point. But in this case, it's no solution. Now we're moving to a little bit more tricky situations, but again, think about simplifying each side separately first, and then combining like terms across the equal sign. So I see an instance here that I need to distribute. So I'm going to distribute. It is a minus 2, so I'm actually distributing a negative 2 to both parts. This 4 is not being distributed because it's separated with the minus part. So I have minus or negative 2w when I multiply 2 times w. Then I have plus from the plus from the parentheses, and then I have negative 2 times 3, which is negative 6. Then I have w minus 6 over here where I can't combine the w and the 6 that way. So I'm going to go back to the left side, and I see that I have a 4 plus a negative 6. I can combine those two because they're both numbers to be negative 2. And then I have minus 2w still left over. So I have a place to start to solve for w, where I have to combine like terms across from the equal sign. So I'm actually going to bring the 2w to be with the w because that will keep it positive. Since it's minus 2w, notice I added 2w to both sides to bring it over to the other side. And I have 1w, which the number next to the variable when it's not written is a 1. So 1w plus 2w is 3w minus 6. And I'm solving for w now, so I'm going to continue to combine like terms across the equal sign. That's a minus 6, so I'm going to add 6 to both sides. And I get 4 equals 3w. And then I'm going to divide both parts by 3 because it's 3 times w. So that's going to give me w equals 4/3. Now, if you wanted to write this as a decimal, that would be fine, but notice that it's going to be a repeating decimal. It's going to be 1.3 repeating. So make sure you write a repeating decimal with a horizontal line over the repeating digits. So 1.3, and I put the horizontal line over. So either one of those answers would be correct. Next one we have is, again, more combining like terms and then solving for y. I see two instances of distributive property, so I'm going to distribute the 4 to both parts, and I'm going to distribute the 3 to both parts in the parentheses. This 3y is going to stay how it is right now because I'm going to distribute first. Minus 4 means I'm going to be distributing a negative 4. So negative 4 or minus 4 times y. And then negative 4 times 2 is going to give me negative 8. And I bring down the minus sign from the parentheses. So this actually becomes a plus 8. Then we have 3 times y, or 3y, minus 3 times 4, or 12. Again, on the left side, I can combine like terms first before combining them across the equal sign. So 3y minus 4y gives me negative y, or negative 1y, plus 8. That equals 3y minus 12. And I'm still solving for y here, so I still need to combine like terms, but I'm combining them across the equal sign, so I have to do the opposite, which is adding here because it's a negative. Think about canceling it out completely, having it become 0 on the left side and bringing it over to the right side. So I have 8 left over on the left side, 4y, and minus 12. So I'm going to get the variable by itself, continue to combine by doing the opposite. So I get 8 plus 12, so 20 equals 4y. Get the y by itself, I would need to divide by 4. So 5 would be your answer. And one more solving here. We have both sides again have distributed involved, so I'm going to do that first. Negative 2 times 3d is negative 6d. The plus comes from the parentheses. Negative 2 times 6 gives me negative 12. Then I have negative 12 times d is negative 12d. The minus comes from the parentheses, and I have negative 12 times 2, which is negative 24. That ends up being plus because we have minus a negative. So negative 6d plus negative 12 equals negative 12d plus 24. Now I'm combining the variable terms. I'm going to bring the 12d to be with the 6d, again because I can get a positive number here. So I'm going to add that, and I have negative 6d plus 12d, which gives me positive 6d. I'm rewriting every time I get to a new step, I rewrite it. And then I have 6d plus negative 12, so I'm going to add 12 to make that 0. and 6d equals 36. So my last step would be divide by 6. I'm running out of room here. And d would be 6. With all these solving equations, I hope you go back at some point, or maybe it's the first time that you watch it, and you try to solve the equation first, and then look at how I solved it. So hopefully that'll help you to check how you're solving. Here we have absolute value equations, or I'm sorry, expressions, where they give you the value of the variable. So with absolute value, you always want to plug in everything first and then take the absolute value of just one number, okay? So you should get what's in the absolute value symbols, which are the straight lines. You should get one number and then take the absolute value. So in this case, we have 4 plus the absolute value of 3 times -2, because -2 is w. So I'm going to do what's in the absolute value symbol, which is -6. And I have 4 plus the absolute value of -6. Now I'm down to one number in the absolute value symbol, so I can take the absolute value, which is going to mean that this becomes +6. So 4 plus 6 equals 10, and that would be my answer. Next I have 2 minus x minus w. But 2 minus x is an absolute value. I'm going to leave the absolute value symbols there until I take it. I have -4 because x is 4. And then minus -2 is going to be outside the absolute value symbols, which ends up being +2. So inside the absolute value symbols is 2 minus 4. That gives me -2. That's the absolute value of -2 is what I just wrote, +2. Now to take the absolute value, I need to make this +2 now, +2. So I have 4 as my answer. I'm going to erase this so that we have some room. To do our last problem. So our last problem is 3 minus w minus x, and that's an absolute value symbols, and then minus x outside. So plug in all the numbers first. So I have 3 minus -2 for w minus 4. And that's all in all in absolute value symbols, and then minus 4 outside because it says minus x. So inside the absolute value symbols, I can do 3 plus 2 because it's minus negative. So that's 5. 5 minus 4 is going to give me 1. So the absolute value of 1 is still 1. So I'm going to do 1 minus 4, and my answer is -3. Then we have a few absolute value equations that we're going to solve. When you think about absolute value equations, you're going to have two answers because absolute value is going to be measuring the distance from the number to 0 on the number line. So in every case, you're going to have the same distance for both a negative number and that same positive number. So in this case, to solve any absolute value equation, I'm going to split it up. And when I do split it up, I can take away the absolute value symbols. So first I rewrite the equation pretty much the exact same without the absolute value symbols. Then I need to put the negative version of the equation, which is changing the number on the other side of the equal sign. So I'm going to change that to a -2 instead of +2. And this is where I'm going to get both my answers. So I'm going to solve for Q. This is a +6, so I need to subtract the 6 from both sides. This is a -2Q, so when I bring it down, it's going to be -2Q equals -4. 2 minus 6 is -4. So then I need to divide by -2, and I say +2 as my answer, because -4 divided by -2 is two negatives divided equals a positive. Then I'm going to do the exact same process on the other side for the other equation. Subtract 6, I get negative 8 equals negative 2q, and I'm going to divide by negative 2, and that gives me q equals positive 4. So my two answers are 2 and 4. Same idea here. We're going to split this up into 2x minus 1 equals 23, and 2x minus 1 equals negative 23. I'm going to solve for x, so I need to add 1 to both sides. 2x equals 24, and then divide by 2. So x would be 12. Exact same process on the other side here, so plus 1. 2x equals negative 22, and then divide by 2. So x would be negative 11. And that concludes our lesson, or our quiz review. And good luck on your quiz on Tuesday.